Hello my dear students, today we learn again sums on Pythagoras theorem part 2. So some more questions we will learn from here today. So exercise 6F, look at question number 4. In the figure, O is a point inside a triangle PQR. Here is the triangle PQR. Inside there is a point O. So if we look this triangle POR, in this triangle, see, it is mentioned in the question POR is 90 degree. So this angle 90 degree is mentioned. That means this triangle POR is a right triangle where OP is 6 centimeter and OR is 8 centimeter. So we can find this PR. PR will be the hypotenuse because this is the right angle. Angle POR is 90 degree. So we find the hypotenuse PR. We write in triangle POR, angle POR is 90 degree, that is given in the question. Also OP is 6 centimeter. Then OR is 8 centimeter. So it is easy to find PR. So we find therefore PR square. This is the hypotenuse from angle POR opposite side. Square of hypotenuse is equal sum of the squares of other two sides. So it is OP square plus OR square. Look here, this is OP and this is OR. We write the value of OP, it is 6 given, 6 square, OR is 8, 8 square. So multiplying this 36 and 8 square is 64. 8 square is 64 is equal 100. 36 plus 64 is 100. So we can find PR is equal square root of 100. Square root of 100 is what? 10. Square root of 100 is 10. Question given in centimeter, so it is centimeter. Now look the original triangle PQR. So now in triangle PQR, see what are the three sides. PQ is given in the question. PQ is 24 centimeter given. We can write here this PQ is 24 centimeter given. QR is given 26 centimeter, that also we can write. So we can write PQ is 24. Then QR is equal 26 centimeter. And just now we have got PR. This PR is 10 centimeter. PR is 10 centimeter. So we have now the length of three sides of the triangle, and look at the biggest side, it is 26. So we will find square of the biggest side, QR square. Square of the longest side, 26 square. 26 into 26. 26 into 26 is, it is 676. 676. And then we will find sum of the squares of other two sides. Other two sides are what? And we can write PQ square plus PR square. PR square. PQ is 24 square and PR is 10. So it is 10 square. Multiplying 24 by 24, it is 576. Plus 10 square is 100. By adding we get 676. So what we see, square of the longest side 676 and sum of the squares of other two sides is 676. So we can say therefore square of longest side is equal to sum of the square of other two sides. So by Pythagoras converse of Pythagoras theorem. By converse of Pythagoras theorem, what will be? By converse of Pythagoras theorem, in a triangle, if we see square of one side is equal to sum of the squares of other two sides, the triangle is a right angle triangle. So we can write the triangle PQR is a right angled triangle. Is a right angled triangle. So that we need to prove. Here prove that PQR is a right angled triangle. So our proof is finished here. And next is question number 5. Look at question number 5. So we adjust our paper here. See what is given in the question. In an equilateral triangle ABC, AD perpendicular BC. This is the equilateral triangle ABC, where all the three sides are equal. AB equal BC equal AC. And AD perpendicular BC. This AD is perpendicular to BC. We have to prove that AD square equal 3BD square. So solution we can write, given a triangle ABC in which equilateral triangle, so all the three sides are equal. AB is equal, BC is equal, AC. All the three sides are equal. And this also AD perpendicular BC. This is given. So we have to prove this. So you can write to prove AD square is equal 3BD square. This we have to prove. Now see the proof. In the proof, see ABC is an equilateral triangle and AD is perpendicular on BC. So we can write, since AD is perpendicular on BC in the equilateral triangle ABC, so what will happen? This AD will bisect BC. AD bisects BC. In an equilateral triangle, if we draw AD perpendicular on a side, then that AD will bisect the side. So we can write AD bisects what? BC. If AD bisects BC, what will be the value of BD? We can say BD will be half of BC. It means BC will be double of BD. So we can write BC is equal twice BD. Have to understand here, if AD bisects BC, we can say BD is half of BC. That means BC will be twice BD. This point have to remember. Now we see AD is perpendicular to BD, so this angle is right angle. So we can say in triangle ADB, what is angle D is equal 90 degree. That means this triangle is a right triangle. Then from D opposite is AB is the hypotenuse. So we can write the square of hypotenuse is equal square of hypotenuse AB square is equal sum of the squares of other two sides. So other two sides AD and BD. And right here AD square plus BD square. AD square plus BD square can write here by Pythagoras theorem. Pythagoras theorem. By Pythagoras theorem. Now we can write, or AD square is equal this AB square. Take this right side, it will be minus BD square. Minus BD square. So we can write is equal. Now AB, this is an equilateral triangle, so AB equal BC. So for AB we can write here BC. BC whole square. This is minus, so BC square just is okay. BD square. Then because we can write here AB equal BC. Even equal AC also, no problem. So this is now net whole square. We can just write BC square. BC square minus BD square. Now is see the value of BC square. This BC we have written twice BD. So we can write here twice BD. This is twice BD whole square minus this BD square. Minus this BD square. So if we multiply this twice BD square, it will be twice BD square we multiply, it will be 4 BD square minus this BD square. The 4 BD square minus BD square, it is what is 3 BD square, and that we wanted to prove. Here we can write this BC equal twice BD. We have earlier proved. We can write here because BC is equal twice BD. We have proved already. So for BC square we write twice BD whole square. Now multiplying 4 BD square minus this BD square. So 4 BD square minus BD square is 3 BD square. So we get AD square is equal 3 BD square, that we wanted to prove. So we can write here again, or we can just stop. AD square equal 3 BD square we have got. So we can write here proved. So next we will have this question number 6. So question number 6, triangle ABC is an isosceles triangle. Look at the picture. ABC is an isosceles triangle in which two sides are equal. AC equal BC. This AC equal BC we can show by mark. If AB square equal twice AC square, this is given. AB square equal twice AC square. We have to prove that triangle ABC is right angled triangle. So we can write solution given from the question itself. Triangle ABC is an isosceles triangle in which AC equal BC. This AC equal BC and this AB square equal twice AC square. We have to prove triangle ABC is a right angle triangle. Here is proof that is a right angle triangle. So we start the proof. We can write since. We will start the proof from here. Since AB square is equal twice AC square, so we can write is equal, this twice AC square we can write as AC square plus AC square. Twice AC square we break as AC square plus AC square. Then is equal AC square plus, we can write for AC, here is given AC is equal BC. So we can write for AC is BC. This is BC because AC is equal BC. A small proof. So is equal, now AC square plus BC square. You see here in this triangle, this AB square is equal AC square plus BC square. That means in a triangle, square of one side is equal to sum of the squares of other two sides. That means the angle opposite to the first side. See here, AB is the first side. Here, square of AB square. AB is the first side. From here, the opposite, this angle will be 90 degree. Angle ACB is 90 degree. So we can write, therefore, angle ACB is 90 degree equal 90 degree by converse of Pythagoras theorem. Converse of Pythagoras theorem. So converse of Pythagoras theorem is what? In a triangle, if we see square of one side is equal to sum of the squares of other two sides, then the angle opposite to the first side is right angle. So from AB opposite is this angle ACB. This is what? 90 degree according to converse of Pythagoras theorem. So if this angle is 90 degree, this triangle is a right triangle. So we can write therefore triangle ABC is a right angled triangle. Right angled triangle. So our proof finish. And look at question number 7. In right angled triangle ABC, angle C is 90 degree. This angle C is 90 degree and D is the midpoint of this BC given. Prove that AB square is equal 4AD square minus 3AC square. So how can we do this sum? We can write here given right angle triangle ABC, given triangle ABC in which angle C is equal 90 degree and D is the midpoint of BC. So D is the midpoint of BC. What we have to prove? We can write here to prove this AB square is equal 4AD square minus 3AC square. This we have to prove. So now we start the proof. See in the triangle ABC, angle C is 90 degree. This is given. So by Pythagoras theorem, see if C is 90 degree in triangle ABC, then from here opposite, forget this line AD, you take this triangle ABC, so hypotenuse will be AB. So we can write therefore the square of hypotenuse is equal sum of the squares of other two sides. Other two sides are AC and this BC. AC square plus BC square. You have to write by Pythagoras theorem. Then is equal, what we see, we can write AC square. Is plus, look this BC. This BC square, this D is the midpoint of BC. So we can say this CD is half of BC. That means BC will be twice CD. So for BC we can write here twice CD whole square. We have to write the reason because D is midpoint of BC. Therefore this BC will be twice CD. We can say D is the midpoint of BC, so CD will be half of BC. So oppositely we can say BC is equal twice CD. And now is AC square plus multiply this 2 CD square, it will be 4 CD square. Now 4 CD square, we have to look here the value of CD what can be. Look this small triangle. In this small triangle, angle C is right angle. So we can say in right triangle ACD, the hypotenuse is AD. So we can write here, the hypotenuse is AD. We can write this AD square, and other two sides are AC and CD. We can write here AC square plus what? CD square. Then we can write here, therefore CD square is equal, we can write here this CD square is equal AD square minus AC square. AC square. So we can write here AC square plus 4 into, look the value of CD square here is, we can write here in bracket this AD square minus AC square. Then if we do here AC square, multiplying this by 4, it is 4 AD square minus 4 AC square. So we can write here this 4 AD square, we write first 4 AD square, and then here is AC square minus 4 AC square. If we subtract 1 AC square minus 4 AC square, it will be 3 AC square, and that we need to prove. Look here what we need to prove. AB square equal 4 AD square minus 3 AC square. So we got AB square equal 4 AD square minus 3 AC square minus 3 AC square. Is it not clear? Oh Baba, every time these things happen. So is here we write 4 CD square is here AD square minus AC square. So 4 into AD square minus AC square for CD we write. Then we multiply this by 4. This is 4 AD square. 4 into minus AC square minus 4 AC square. So here is 4 AD square, then AC square minus 4 AC square. If we subtract, it is minus 3 AC square. So we get AB square is equal 4 AD square minus 3 AC square, that we needed to prove. To prove AB square is equal 4 AD square minus 3 AC square. So we can write here proved. So thank you my dear students. We'll meet in the next lesson.